Hi there. As I explained you earlier, my aim is to explain you regarding what is simple harmonic motion. Why do we call this one as simple harmonic motion? I just gave you a certain hint. Why? Because certain complex motion of a certain object. Imagine the object is vibrating in a multiple vibrations and its source of only one simple vibration as a resultant periodic vibration. So if that might consist of different things, as I mentioned it in blue color and red color and yellow color and green color, four different vibrations all together gives out a certain resultant vibration as a result of it. Imagine if the resultant is something like this. So this is the output of a certain complex vibration. So why do we call it a simple harmonic? Because this, as I mentioned earlier, this is consists of several vibrations together. If we just unearth each of these single vibrations simply one after another, how? Right? If we get one vibration apart from it, so I'm not going to damage this main diagram, and I'm going to do that with something different. Here is the same diagram and in the minimized version, so I'm going to release one of these, right? One of these diagram. So one is released, the other one I'm going to release it, the red one. Red one is released now, yellow one is going to get released, and the blue one is still there as a one vibration. So we can analyze the property of each now separately. This one separately, this one separately. Now aren't they simple? If I name these ones as after A, B, C and D, now I separated each and going to observe each case separately and carefully. So these things are now simple vibrations. This is why we call simple harmonic motion. Why? That is the simplest form of a vibration can occur in a certain complex vibration. Okay, further more explanation. Have a good look at. If certain consists of a body or anything, rock, whatever, consists of matter. Matter may consist of elements, compounds, or molecules. If we break them further, we get the atoms. So, good example, glucose molecule, a very simple carbohydrate. It consists of C6H12O6. That means it consists of carbon, hydrogen, and oxygen. So each of these atoms like a carbon, it's like a one of those oscillation, simple harmonic motion. It may consist of certain other properties, like of this one, the atom consists of protons, neutrons, and electrons, and orbits, and many other things. No? Like the same way for atoms, simple harmonic motion, one motion may consist of period, frequency, amplitude, distance, velocity, acceleration, and phase. We are going to learn these things in very soon in this particular video. Let's move to the next slide. Now you have a clear idea why do we call this one as simple harmonic, because it is not that simple, because it has certain complicated theoretical stuff and the mathematical models for these things, but we have unearthed one simple one and following all the properties of that simple oscillation. Okay, that's why we call it as simple harmonic motion. Okay, in the next one, let's get some examples. This is a vibration of a certain mass hang in a spring, so it may just vibrate up and down in up and down motion. This is a certain pendulum. It's a good example is a swing. So clock pendulums, so the pendulum swings back and forth in certain directions like this. So this is a good example for a certain simple harmonic motion. If you fill a certain YouTube and just tilt it and release, then the water column just move up and down like this way. So it is a good example for a simple harmonic motion. Now if you just try to move up and down, it's like a good example is to just press a certain rubber ball just below the water surface and release it. It will just move up and down. It is a simple harmonic motion. The pendulum extended again, and a motion of a back and forth motion of a hacksaw blade. You may have tried it, or you may try it with using a longer ruler on your desk. Keep it on and tap on the one of the free end, then you can see the up and down motion of the end. It's like a also a good example for simple harmonic motion. Okay guys, let's go for the mathematical analysis. Just before that, we have to understand one of the really important thing. The objects are going to move from one end to another apart from certain fixed point. If I get the previous one, so this is the fixed point. The stuff reach to an extreme and comes down to from this one. So the initial height to a certain extreme height and move down with a certain lower height. So that's how it is. So there is a certain extreme point that's known as the amplitude. We will learn very sooner, and the other amplitude of the negative amplitude, and the mean equilibrium position or central point, whatever it is. So the good example is this spring. This is the normal position of a mass attached to a spring. It is not moving. Now if you drag it, like extend the stuff, now it's extended to certain distance of x, the amplitude of x, and you're going to release it. Sources of certain force that is called a restoring force. It is directly towards the center. Always remember that the force is always towards the center. If you are just moving to other direction, then the direction changes always towards the center. Now it releases and comes to here. It is not going to stop here by here because it's moving at a faster now. It's going to go up other direction and stops because of the restoring force generating towards the other direction. Now stops momentarily and moves. It is going to move back and forth along a certain smooth horizontal stable. That's really simple. This is a type of what simple harmonic motion. You have to have a good understanding about the mean position, from the mean position to both directions. So a good example is this point. So have a good look at it. It is just going to move, start from a normal velocity with a very high velocity and slow down and comes back. It is going to move back and forth like this way. Now in the next page, so the definition. What is the definition of a simple harmonic motion? The motion of a particle whose acceleration is always directed towards a fixed point and directly proportional to the distance of x of the particle from that point. That means the acceleration is always towards where? Always towards the center. The acceleration is always towards the center, right? The acceleration is always towards the center. For this one also, the acceleration is towards center, acceleration is also towards the center, and the force is always towards the center. So now we can write the acceleration is directly proportional to the x, and it is the opposite. That means inversely proportional to that. When you just extend it, they're always towards the center, not from the distance towards the displacement. That's why I include the negative sign. So, and also the force is also directly proportional to x. I'll show it. So you can just put a certain proportionality constant for the first one, and you can make it like minus kx. Okay, now I'm going to apply the Newton's second law of motion. F equals to ma. Now my a is nothing other than this one. Now I may write it the equation like so this way. Have a look at F is equals to minus mkx. So this is a new constant now. So I can take this one as k dash. So I may write it like this way. M proportional to minus k dash x. So this is now also, you can show that it is proportional. It is also directly proportional to the x, negative x. This is what you just need to understand. You will know how to derive this equation in future, but I'll give you just for your convenience. So there is a certain characteristic equation for all the possible simple harmonic motion. So this is one of the stuff, and the next one is the very characteristic one is minus omega square x. Just remember, because for the A levels you do not want to prove this one, but I'll teach you how to prove it in future of this video. Okay, what is A? A is the acceleration, and omega you already know in simple circular motion. That's the same omega is what? Angular velocity. velocity, and x is the displacement. Okay, I'll give you some really important points to you to use here, but before that I have to explain you really important points regarding simple harmonic motion. What are those things? So the characteristic curve is like so what when the extension is always away, remember the acceleration is reducing and reducing and reducing. So see, so the other direction, so when it so extension sorry acceleration is increasing as it move, this is the negative x and the negative is positive, so the acceleration is the same way and the force is always increasing in the opposite direction. And now what is a complete cycle? I'll explain you this one, but I'm just going to start the motion from some end like this, the equilibrium position to middle position. You have to just travel from here to reach there and comes back. Only half the cycle is completed. Now you have to go past that point and to reach the other extreme and comes back. This is it. Now if you start certain likes of previous thingy, likes of a certain spring type of thing, so the stuff is going to move towards here and reach to here and go back to the other extreme and comes back. Or you may start the stuff from one end, now you may reach to the other end and comes back. So that type of motion, you start from the far end of it, so you have to return to the same end. So this is really important to remember. In the circular motion relationship, you may start it from top of the x-axis or top of the y-axis. So from this point you have to reach up and reach down and comes back to original. So here it is only starting from bottom, top and reach to bottom and comes back. Somehow you have to complete the cycle. These are two different things you will immediately learn. One is a x sine cycle, the other one is a cos cycle. It's really important to remember and have a really good look at these type of trivial matters as well. It's really important. Next part, some important definitions. Time period. What is time period? It is the least interval of time after which the periodic motion of a body repeats itself, or you may write it like time taken to complete one cycle. That's also a good definition. Time takes to complete one cycle. Guys are really struggling at remembering this point because it's not a big deal. You start from here and you reach to there, and it's a periodic motion. That means it's the completes with some periodic time, like so of the earth is revolving around the sun, it's like a 365 days, and the earth revolves itself like 24 hours, and the moon is revolving around the sun, earth, it is like so of 28 years, like something like the second hand of a clock. It's revolving around one fixed position after each 60 seconds. Like a certain fixed time period, it is known as a periodic time, and the frequency is a really important thing you to remember. So normally we write this one as this way in this combination of circular motion, 2 pi over cap omega. This is one of the usage you have to use. And another thing, frequency. What is frequency? It is defined as the number of periodic motion executed by body per second. SI unit of frequency is hertz. Or other way, you can write that number of cycles per unit time. You may write number of simple harmonic cycles per unit time. Number of cycles completed for unit time of an object in SHM. Okay, so the equation is going to be something F is equals to omega over 2 pi. So you may just cross multiply this equation and remember in a user friendly method of likes of omega is equals to 2 pi F. And the angular frequency is something like the same way. So have a good look at it. Is like here, n is stands for the F, so no problem, it's the same thing. And the very next one, it is like a displacement, and I'm going to explain displacement thingy and phase in future video, the very next video, not in this one. So I'm not really interested in reading it out even. So if you want to, just pause the video and have a good look at and sine cos variation. I will explain all of this, so just read it if you really want now. So let's move back to here and write those important data that I told you to remember, those important data to apply this in these equations. Remember this very extremely important equation: 2 pi over omega. T, capital T stands for the periodic time. T stands for periodic time. Okay, the other one is going to be, what is the other one? F is equals to omega over 2 pi, the opposite of it. So another equation you have to remember, F is equals to 1 over capital T. So you know that this one is the inverse of this equation, reciprocal of that one. Simply, so you may just cross multiply this equation and obtain omega is equals to 2 pi F. If you forget this equation, you may really suffer. So it's really important to remember each of this set of data equations, and may just write a short note or something from this one. Okay, now let's move forward. Now I want to explain you the relationship between certain simple harmonic motion and circular motion. The topic is relationship between SHM and circular motion. Okay, now have a good look at certain object which is just moving up and down, right? We can use certain ticker tape or something. You just can just drag your a certain A4 sheet to one direction, and one guy just moving the pen up and down. You may just get this type of nice curve. You may see there is a certain hint of what? Semicircle, another semicircle. If we join these two things, it looks like a circle, isn't that? So there is a certain fixed relationship of what? Rotational motion and simple harmonic motion all together. If you just move certain motor with a certain plate and you just attach a certain LED bulb or certain laser light, so you may see the laser pattern on the wall or screen like this. So it represents this one. See the amplitude, the radius, actually the radius is the amplitude. It just draw this type of pattern, and pi over half, and I will tell you what are these things there. So you may have two different curves. One is a sine curve of this one, the other one is a cosine curve. Remember this one, if you start it from this horizontal position of the x-axis, it is always the sine curve. Sorry, if you start it from this point, and sorry, it's cosine curve, and measure the angles on the opposite direction, it is always making the cosine curve. And if you are starting from certain y-axis point, top or bottom, so you may get sine coordinates, sine cycle for the x direction. I'll explain you in the next slide. So you have to have a good understanding. If you're starting from this point, it is the cosine curve. If you're starting from any of these y extremes, it is going to be a sine curve. That's something you have to remember. Okay, let me explain you the relationship of simple harmonic motion and the circular motion. If a certain object, if it's like this type of object, so the object is going to move from one point, so it is going to start from here and reach to some higher point. It is what cycle now? It is the cosine cycle. Now I'm not going to get that one, because for the easiness of the definitions and the user-friendly equation to get, I'm going to start it from where? Top of the cycle. Okay, in the previous one, in my previous diagram, it was like this one. You started from the bottom and you reach to top in an anti-clockwise motion.
So no problem. Here I'm going to start it from top and moving at where? Clockwise direction. It makes no difference. Okay, it makes no difference. Now it's starting from here. Now it has moved to some distance here, an x distance it has made in the x direction compared to that. And the biggest thing is it's now has made an angle over here. The angle value is theta. This one is also theta in terms of what these two are alternate angles, because this is a 90-degree perpendicular x-axis and y-axis. Started at top, starting point is top. As I mentioned, it's going to be a sine cycle. Now let's see how to get the sine of this one. This one is the amplitude of A, because the radius is equals to the maximum possible displacement it may made from here. X displacement is going to be the amplitude. Amplitude is equals to the radius in this sense. So the radius is equals to the amplitude. So now how to get this equation? I will just draw the triangle from here. I'll just copy this triangle. So the triangle is like, if I name it after like, sorry, P, Q and R. PQR. So the angle, it is theta over here. This is x, and this one is the A is the hypotenuse. So the sine theta is what? Sine theta is equals to x over A. When you extend it, you may get the first set of mathematical expression obtained from this equation. Previous ones were not obtained. It was just something to you to remember, and these ones were from previous lessons like circular motion. The first time this equation is already given to you to remember. It is not derived yet. So the first derivation is going to be this one. So when you cross multiply it, you get the equation as x displacement is equals to A sine theta. This is the first equation you derived from it. Okay, now how to relate this thing with the circular motion? You know that omega is equals to theta divided by t. So cross multiplying of this one, you may obtain the equations like of what? Theta is equals to omega t. This is equation number 1 and this is equation number 2. So your inclusion of equation number 2 into equation number 1, so you may obtain it is like what? X is equals to A sine of omega t, and this is a really derivation. So you'd better remember this one as well. In the simple harmonic motion, there are some other equations you may not need to remember at all even, but this one is really important to remember, and this one is really important to remember. Even though you don't know or know, you have to remember the previous one as well. What is the previous one? This one. I will teach you how to get it, but it's not really essential, but you have to remember and how to apply it. Okay, now the very next part is, now you have already obtained the simple equation from this one. Now if you started it from here, what is the equation shape is going to be? I told you, if you started from here and made certain motion, now in this sense it has just moved in a certain angular velocity of omega. No problem, it's just came to here. If you started from here to upward, what is it going to be? Now the theta comes to here. Now it is going to be the cosine cycle. In the same similar pattern, you may just write it like the way. This is the sine cycle, and the cosine cycle. X is equals to A cos omega t. So just keep this one in your mind as well. The cosine cycle, whether simple harmonic motion can be interpreted according to cosine cycle or sine cycle, both take place simultaneously according to the mathematical model. This one is like so this type of cycle, this one is a vertical cycle. That is the difference. This is a vertical cycle and this one is a horizontal cycle. That is it. You don't want to know that extent, but only remember this equation and the shadow of that one or the mirror image of that one is really easy, because if you started from here and it's a cosine, this is the cosine cycle. And if you start from the top or bottom of the y-axis, it is going to be the sine cycle. That's really simple. Now the finalized equation, it's going to be what? Something like y is equals to a sine omega t. You may see the amplitude, wavelength, and the lambda. There are certain very important relationships are there, but I'm not interested in explaining you those things right now. This is a very basic explanation. In the very next video, I'm going to give you some calculation related to this exact particular theory. This is the theory video. In the next one is going to be the calculation video. After that, next set of the theory of simple harmonic motion, and after that one also the calculations. And I'm just planning to make 6 sets of I'm just planning to make 6 sets of videos for you. God bless you.